morning. I'm going to go through the corrections of the classwork I asked you to do yesterday with tree diagrams, and then the homework that I asked you to do as well. So we're going to start with question 5. Question 5, part A. I didn't ask you to do part B, which involved a two-way table. I just wanted you to practice with the tree diagram. So we were told that 2 coins were flipped and they could end on either a head or a tail, and you have to copy and complete a tree diagram for this. So for the first flip, we could either have had a heads or a tails, and then for the second flip, we again could either have had a heads or a tails, and then of course we had to list the possible outcomes. So this one was heads followed by heads, this one was heads followed by tails, tails followed by heads, and tails followed by tails. You don't have to, but it's good practice to number your outcomes as well, because then we can see how many of them we have in total. Okay, so that was 5A, and that's all we needed to do with that. I didn't need you to do anything else, just listing the outcomes. Question 7 then, another tree diagram. This time a coloured spinner was spun and it could land on either green or blue. So it's very similar to the previous one. For the first spin, it could land on either green or blue. And then for the second spin, it could land on either green or blue after green, or green or blue after blue. And the important thing here to keep them neat is that you line them up vertically like this, okay? It doesn't matter how much space is between them. You must always list your outcomes or your tree diagram is not complete. So the first one here, green and then green. The second one here is green and then blue. The third one, blue and then green. And the fourth one, blue and then blue. So our 4 different outcomes there. And that follows from the fundamental principle of counting, the idea that you've got 2 times 2. So you have 4 in total. And finally, what I asked you to do was the tree diagram. So finally for classwork, question 8, part B. You'd previously done question 8, part A for homework, where Colin was either late, early, or on time for one of his classes. So this one was a little bit more complicated. So you've done a two-way table, and here we're going to do a tree diagram for the same information. So he could be early, we're using T for on time, or late. Give plenty of space between them because I need to fit in 3 again for the second one. So this is his first class, and then he, after being early for the first one, for the second class, he could be early, on time, or late. After being on time for the first one, for the second one, he could be early, on time, or late. And after being late for the first one, for the second one, he could be early, on time, or late. Now, you can see how they're stretched out like this. So the idea is to keep them neat, you line them up vertically. I know I keep saying that, but people's tree diagrams tend to get out of control, especially when you have 3 outcomes per trial. Now, we're not finished until we list our outcomes. And this one, the first one, is early and then early. The second one here, early then on time. The third one, early then late. Here he's on time then early, on time for both, on time and then late, late then early, late then on time, and late for both. So we have 9 outcomes in total. And again, that makes sense from our fundamental principle of counting, because 3 for the first trial, 3 for the second trial gives us 9. With the spinner, 2 outcomes for the first trial by 2 outcomes for the second trial gives us 4. And the same idea with the coin flip, 2 outcomes for the first coin, 2 outcomes for the second coin gives us 4. So that's how you do a tree diagram. You might let me know if you had any problems doing the tree diagram, that you feel that if you feel that you couldn't do these again in the future, because they're very, very important in probability. You'll need to be doing these all the way to Leaving Cert. Okay, now I'm going to move on and correct the homework as well. So for homework, you were doing some probability calculations. And the first question you had was question 4. Just make sure this is on screen. Question 4. And there was a probability scale shown. So I'm just going to copy that onto my paper here. The probability scale, of course, goes between 0 for impossible events all the way to 1, 6, 9, 12, 15, 18, 20. I've gone a little bit too far. Just go here. All the way to 1 for certain events. So in between 0 and 1. There's my halfway point there, 0.5. And all the values in between. Can get messy if I fill in every single number. But I suppose because it did on the homework question, I'm going to fill them in. So sometimes it's enough to use the marks. 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, 0.8, 0.9. And as percentages, this would be 10%, 20%, 30%, all the way to 90%, and 1 represents 100%. And we were filling in where on this diagram different events would go. So event A was already filled in for us. This was when a fair coin is flipped. And we say fair because it's not more likely to land on one side than the other. We'll be talking a little bit later about when things are unfair, when it's not balanced, for example. Okay, event B, the day after Saturday will be Sunday. Well, that is certain. The day after Saturday is always Sunday, unless we change the calendar. It will rain tomorrow. Okay, it's Ireland. It's fairly likely that it will rain tomorrow. And to be honest, it's raining right now. So I would probably put this up at a 90% chance of rain tomorrow. But, you know, if you filled it in anywhere between 0.7 and 0.9, I'd accept your answer there for part C. And let me know in a comment if you're not sure about one of your answers. Part D, you will throw a 1 or a 2 on a fair standard 6-sided die. Okay, that's around a third probability, so it should go in here. Okay, it's not exactly on 3, it should be about 33%. You will pass your next maths exam. You know, I want to put it in here, guys. I really hope that you'd all feel confident that you'd pass your next maths exam, especially in probability. You will draw a club from a standard pack of cards in a single pick. So a club is a quarter of the deck. So that's about 0.25, and we put that here. F. And you will live to be over 200 years old. Is it impossible? Is it exactly 0? Well, you know, medical science is increasing all the time, so maybe we won't put it exactly on 0, but fairly close to it. It's unlikely that we're going to live to be over 200. But things are progressing fairly well, so you never know. We won't put it exactly at 0. Maybe we'll all live to be 1,000 if things go well. Okay, so there's the answer to part 4. Now, you might have had slightly different answers, and that's fine, but if you don't understand how we're meant to use the probability scale to line up events like this, just let me know and I can go over it in more detail. The next question you had was question 5, and we're asked to copy the probability scale that's shown, so we're using a probability scale again. I'm going to draw it down here between 0 and 1. So I go from 0 to 1, and 0.5 is in the middle. And then every 2 boxes, the way I've drawn it, I didn't line up my 0.5 very well. Every 2 boxes, we've got the other values. So place the letters L to S in the correct position on the probability scale below. K has been done for us. So K has a probability of 3/4. We're going to fill that in here. 3/4, 0.6, 0.7, 0.75. So they filled in K here at 0.75. If it helps you, you can write in the number underneath as well. The next one was a 50% chance. So L goes here. A 50% chance. Likely. Now, likely can be anywhere in here. So this is likely. We might say that that's very likely. So you don't have to have this exact. This is M. You might have had this closer to 1 or closer to 0.75. Likely should not be below 0.75 though. So anywhere there is good for likely. 0.25, 0.1, 0.2, 0.25 should be there. That's N. 0. Okay, well we have 0 filled in here. That's Q. Definite. So definite means certain, which means 100% probability, which means 1. So or goes up there. And very unlikely. Unlikely, anything less than 0.25. Very unlikely. Let's put it quite close to 0, but not exactly on 0. And again, you might have had it anywhere between 0 and 0.1. Anything less than a 10% chance we would call very unlikely. Which events are more difficult to plot on the scale? And give a reason for your answer. So the ones without a number. Oh, I skipped P. I apologize. Almost certain. So P can go in here. This is about a 95% chance. Put P in there. Yeah, and I didn't skip any other ones. So the ones without a number are the most difficult to plot. Why are they the most difficult to plot? The most difficult. So like certain, almost certain, very unlikely, likely. Because there are a few different values. There is a range of values. There are a range of values where these words, what words? For example, likely would be correct. Correct. Okay, my spelling is bad this morning. Okay, I hope that's clear. Often these sort of explain your reasoning questions can be difficult for people. So of course you don't have to write down the answer exactly like I've written it there, but something like that. When we have a number, it's very easy to plot it on the probability scale because you know exactly where it has to line up with. But when we're talking about a word like likely or very unlikely, there is a few different values where the answer is still correct. So your probability scale should look similar to mine, but it may not be exactly the same. And question 6, you were asked to make up your own events. Now, this is the kind of question which would be great to do in class. So we just have to do our best. I'm going to give some examples, and you'll have to judge for yourself if your answers were correct. And if you're not sure, what can you do? You can just ask me in a comment, and we can have a discussion about it through Google Classroom. So again, my probability scale goes from 0 to 1, with 0.5 in the middle, 0.1, 2, 3, 4, 6, 7, 8, 9. So there's my probability scale. And these different events were filled in like this. So we had A at 0, B, something a little more than a 10% chance, C, right at 0.3, D, right at the 50-50 mark, E, about a 65% chance, a little bit less than 90, we have F, and G, we have something certain. So let's write down some different events here. A, B, C, make sure that you can see these. A, B, C, D, E, F, G, and that's it. So A is something that's impossible. What's impossible? That I will shoot a fireball from my eyes. Anything at all. You can have fun with this and make it ridiculous if you want. But anything impossible will work here. From my eyes. Okay, let's go to something that is certain, something that is definite. Well, I think it's pretty definite that we're not going to be in school tomorrow, unfortunately. So we're not going to be in school. We won't be in the school building tomorrow. B, something that's unlikely, but it could happen. Something fairly unlikely, but it could happen. I suppose that I will see my parents this week. No, that's not going to happen. That's impossible due to the coronavirus situation. Unlikely. I'm unlikely to go and play the lottery. I just don't usually play it, but if the jackpot was very large, I might. So, but I will play the lottery. Something that's about a third chance. That I'll let my kids play iPad after lunch. I like to play with their iPads, but I don't always let them. D then, 50-50. Okay, that's fairly easy. Heads on a coin flip. 65% chance. So not super likely, but a bit more likely than 50-50. That I'll buy chocolate next time I go to the shop. I don't always. Next time I shop. That's something that's really likely. Okay, really likely, but not certain, not definite. Okay, that I'll cook potatoes for dinner. I haven't decided yet. Anyway, you guys, so this is all about me, and you guys will have picked your events that work with your life. So the idea there is things that have a certain probability, a certain likelihood. It's a bit fluffy, there's not an exact number on these. So we're ranging from things that are impossible, pretty unlikely, a little bit more likely, 50-50, getting a bit more likely, super likely, and definite. Now, okay, so I think that was it. Yeah, we're going to stop there, and I have another video coming with a few notes for us today.